government and non-government organizations, and now he is a government engineer as well as he's a professor, and he have done lot of consultancy works regarding the water treatment and those things, and he is a designer in sanitation systems. He had nearly 15 years of experience in this field. I think this session on this topic about treatment of water with the biosand filter is very essential at this occasion, because as we Indians as well as the Brazilians have a lot of perennial and non-perennial rivers, as well as we have a lot of groundwater. But even though we could not able to drink potable water, which could not able to satisfy the standards of the government as well as the basic parameters. So we people are spending each and every day of $1 to $1.5. That is nearly 3 to 4 cans of water, nearly 60 to 100 liters of water, which is around 100 to $200. And in a year, if you think that we are spending nearly $1,000, I think. So, for water is a basic and essential need of every human being as well as animals. But as a human being, if we can able to afford a water, but we could, animals could not able to afford it. But what we people are doing actually, we people are grabbing the pure water which belongs to all the living things in the earth. What it means is actually the good water, which is a better quality, we are taking to our treatment plants and we are treating it and we are commercializing it. I think so. But it is not necessary and it is not good for the future. So that what we can do is we should go for an alternative method, economically it should be viable for every citizen or every human being, as well as that should not harm or that should not impact the social environment. Now our chief guest, Dr. Rafael, will give an elaborate and sorry for the inconvenience due to internet problem. I could not connect it. I think this session will be very elaborate and deep in this water treatment with the biosand filter. I hand over this session to our beloved professor, Dr. Rafael. Thank you, sir.
So, thank you for the presentation. I will present a little bit of my work. So what I will present here in this webinar is a little bit what I'm working here in Brazil. I have a good experience in water treatment and wastewater treatment, focus on decentralized systems. So I think it's very important to us in this, like in this moment of pandemic. So I think it's very important about talking about water. So I will present here a little bit of this, okay? So everyone is seeing the presentation?
Yes, sir. Yes.
Okay. Okay, so I will start, okay? Well, I will talk about household water treatment. A Biosand filter is one of the techniques that is used for household water treatment. So I will talk a little bit about it, okay? I'm assistant professor in the Department of Engineering and Environmental Technology in the Federal University of Santa Maria in Brazil. Okay, so I'm very glad to be invited and discuss a little bit about water. So, like the professor has presented, so we are like two countries, Brazil and India, and now we are talking about water. So it's very important to us to talk about it, you know. So here is the four topics that I would talk about now. Is like the first one is water sanitation hygiene, a little bit of slow sand filter, so the theory of this, and the slow sand filter in intermittent operation, and so that is called Biosand filter. And the last one, I will talk about the household multi-stage filtration. That was a part of my postdoctorate that I made. And this is a very good study that I got last year, and very important too, okay? So the first one, water sanitation hygiene, that we call WASH. Yeah? So when this have started with Hippocrates. Is a Greek philosophy. He suggested that the development of diseases in human could be related to factors external to the individual. So some of these factors may be related to the environment. Okay. After that, we have John Snow, and in England, and his analysis and response to the cholera epidemic in London in 1854. So this, he's the father of epidemiology, and his hypothesis was that during the epidemic of cholera in London, his hypothesis was that the Broad Street pump, water pump in the middle of the city, was contaminated. So the water was contaminated. It's important to note that in 1850s, they did not know about microorganisms, but with all his study, he could suppose, so his hypothesis, that the water was contaminated for something. Okay. With that, what we got is some epidemiology studies, and the multiple factors like environmental, social, and economics, they are related to a lot of diseases. And in the world, there are more than 2.5 billion people who do not have access to sanitation. And of this, 71% live in rural areas. As a result, we have a lot of waterborne diseases that affect mainly the poor regions of the world. And for example, we have in Latin America and South of Asia areas, including indigenous and rural population. And all these things, the poor sanitation and no access to water, no access to wastewater treatment, we have a lot of types of waterborne diseases. So we have like diarrhea diseases, cholera, gastroenteritis, giardiasis, and so forth. The high incidence, the prevalence, and mortality, such as acute diarrhea diseases in children under 5. So the waterborne diseases, they affect mainly children under 5 years old. And also we have a lot of researchers that let's say that physical, economical, social, and environmental impacts for the entire community. So the waterborne diseases affect the waterborne diseases have impacts for the entire community in physical, social, economic, environmental, and as the chronic impacts on child mental and physical development. So for children under 5 years old, these waterborne diseases are very, very important in impacts in the mental and physical. So this is the more important thing about the water treatment, okay? The access to a secure water, so in quantity and in quality, okay? So what is basic sanitation? Basic sanitation is we have four things. So the water, access to water, wastewater treatment, access to a drainage of rainwater, and access to solid waste. So all these things, they are fundamental to a good health and to social and economic development. So the adequate sanitation with a good hygiene and safe water. So what we call WASH. We need to know that the World Health Organization said that these three things, sanitation, hygiene, and safe water, they are important for all people. They are human rights. That is most important thing to know. Okay, there's three little words here, sanitation, hygiene, and water. They are human rights. So an ideal solution to problems related to waterborne diseases is access to water. So this access to water needs to be universal, cheap, safe, and constant. Okay. So we have focus on more simplified and viable technologies. This technology needs to be economically, socially, environmentally, and culturally in urban areas, as communities are smaller and households are far from each other. So we have like 4 or 5 and more technologies that are viable for this kind of communities that are smaller and the households are far from each other. So we have the priority purpose is to find a technological solution for household water treatment that are suitable, that are sustainable, and that then can be maintained by their users with little technical support. Why this is important? Because we not want the technological solution to be abandoned in the future. Why we say that? Because we have a lot of technological solutions that the user, they do not, probably the solutions is so complex that the user do not use it. So they abandoned the technology. So for us, it is not important. So that's not good. So we need a technological solution to be sustainable in time. Okay. The second part is the slow sand filter, a theory of that. Among the widely accepted technologies for water treatment in a small community, there's the slow sand filtration. Okay, this slow sand filtration is originated from Britain in the 19th century and was widespread in Europe and in America. Here we have a picture on the top. So the filters, so the slow sand filter, they are big because the flow rate is very low, okay? But it's very simple to operate. And the slow sand filter can bring us a very good treated water with quality. Okay, so in the top of the filter, we have the Schmutz deck, that is a biological layer here, and the water comes, the raw water comes in the top, flow through the sand, the gravel, and the underdrains, and go out treated. So the is a very simple technology that can be used for a small communities. Okay. The advantage of this slow sand filtration. The slow sand filtration has 0.6 to 1 meter bed of sand that is used to improve the quality of water with removal of turbidity and pathogens, mainly. Simplicity of design, simplicity of construction, operation, and maintenance. And it is capable of promoting effective removal of pathogens and particulate matter. So especially due to the trapping of in the smaller sand grains. So the sand has very small grains. So the pathogens become trapped inside the sand grains. Okay. Some disadvantage of this technology: it requires a good quality raw water. Sometimes we can have pre-treatment steps. The flow rate is, like I said, is very low, so 0.1 to 0.4 cubic meter per square meter per hour. So for a big population, it need a large area. But for smaller communities, this technology is very important. Okay. And we usually need days to weeks to develop the biological layer that is called Schmutzdecke. Okay. Consequently, we need to improve the efficiency in this period of time. Okay. We need to know that the slow sand filtration is like 90% is biological. So we need that the microorganisms in the biological layer need to have time, to improve the efficiency of the filter. Okay. The community scale systems are technically more complex, more professional, able to implement, and cost more, and also require a high degree of cooperation among individuals in the community. So it's a kind of technology that can be used in community scale, but in this type, we need a high degree of cooperation. Okay. And we have also the household water treatment, or called point of use, in a way to improve access to water for million people. Here I brought you some examples of household water treatments, like boiling, like ceramic filter. This kind here is very useful here in Brazil. Okay, in rural areas, we have a lot of ceramic filter. I also have the solar disinfection called SODIs, and chlorine. Okay. Another household technology is the household slow sand filter that is called Biosand filter. Okay. The Biosand filter is an intermittent way to improve water quality. Okay. And it's very similar to slow sand filtration. So the Biosand filter was first constructed by Professor Mains in the 90s. Okay, in the 90s, the Professor Mains is a professor in University of Calgary in Canada. So he brought this household slow sand filter. Okay, and it's very simple. Okay, we have here, we fill the filter with raw water. The water passes through a diffuser plate here. After the diffuser plate, the water pass through a descent column, define gravel, and go up to a outlet pipe, and the water is treated. What are the mechanisms acting for pathogens removal? The first one is depredation. So in the top of the sand here, the sand column, we have a biological layer. Okay, so we have predation there. We have trapping, because some pathogens, they are larger than the sand grains. Okay, some pathogens can be absorbed. Okay, então absorption. Né? So some pathogens get stuck in the sand grains, and natural death, because here the pathogens do not have enough food, do not have enough air, oxygen. Okay, so these four are the mainly mechanisms acting for pathogen removal. So this is low sand filter intermittent operation. So the Biosand filter has a diffuser plate here that protects the top of the sand and the biological layer, okay, from being damaged. We have in the top of the sand column, we have the biological layer. We have a filtration sand that removes pathogens and suspended solids from water. So the filtration sand is specially selected and prepared to treat the water well. Okay, so this is the most important part of the Biosand filter is the filtration, is the sand. So the grains need to be very, very small. In the bottom, we have the separation gravel and the drainage gravel to drainage all the water here and support the separation gravel and prevents the sand to going into the outlet tube. We have the outlet tube here, and after that we have the safe water storage. This part is very important too, because we have here, after just the Biosand filter, we have a very good quality of water, drinkable water. But sometimes the safe water storage here is not clean. So the water is safe, but here sometimes the safe water storage is not safe, it's unsafe. So this storage, the packet, that the container, okay, the container to storage the treated water needs to be very clear, okay, to not contaminate the water again. So the Biosand filter is treatment of domestic water to 20 to 60 liters per day. It contains about 0.4 to 0.55 meters of sand above a gravel under drain. So for practical for household use, that is very important that Professor Maines that made the Biosand filters is that the total height of the filter makes it easier to any adult to fill the filter, the Biosand filter, with water. The outlet pipe collects water below the under drain and extend along the filter wall until approximately 5 centimeters above the media surface. So the filtering bed is always kept saturated. This is important too. A diffuse plate above the level of water protects the biological layer from damage. Okay. The advantages of the Biosand filter: construction with local and simple materials, low cost. Here in Brazil, we have like, I don't know if that's like $25, okay, the cost of the Biosand filter here. Affordable and durable, operation and maintenance economically viable, and can be carried out by the resident. This is important, very, very important. And this Biosand filter can be built, operated, and maintained by a layman with few hours of training, okay? Some disadvantages is the size of the sand grains for the performance of the filter. Sometimes it's difficult to find the sand with the little size grains, okay? A disinfection step is recommended, especially when the raw water presents high turbidity. The presence of the biological layer formed in the first centimeters of the sand filter media is the same discussion of this low sand filtration. So we have a biological layer here that needs time to be mature enough to have a good efficiency. And have material. Professor Mains made the Biosand filter in concrete. So people need to have a knowledge about civil construction, okay? But here in Brazil, we have some Biosand filter performance. We have some studies here. There are 3 or 4 groups here in Brazil that works with this. And I brought here some results that our partners have in the performance of this low sand filtration, okay, at the Biosand filter. So intermittently, so we need to fill it with water 1 to 4 times a day. We have a maximum filtration rate is like almost 10 cubic meter to square meter per day. The Biosand filter needs a pause period, the minimum of 1 hour. The efficiency decreased with the temperature. This was a very good result. And it depends on the filter maturation, okay? But the Biosand filter, the turbidity below the value recommended by the World Health Organization, that is 1 NTU, okay, the turbidity. And when the Biosand filter is working intermittently, it has a higher reduction of microorganisms linked with the longer pause period. When the Biosand filter is working continuously, it depends on the constant input and controlled water. So here was a very important thing that we do here in Brazil, that we can work the Biosand filter working with it intermittently, or the Biosand filter can work continuously. So it is going to receive raw water continuously. Is a very important too. Continuously, it depends on the raw water quality. The efficiency decrease also with the temperature. It depends on filter maturation too. The reduction of microorganisms can reach 99.9%. So this filter is more efficient compared to an intermittent Biosand filter. Okay, and the maintenance, when the filter need a maintenance, the filter needs time to recover the performance. Okay, what is the filter maintenance? So we have a biological layer in the top of the sand bed of the Biosand filter. And when the daily production is not as desired, we need to clean the filter. Here with my partners, we have two technologies of Biosand filter. We can put a no blanket on the top of the sand bed too. When we have a no woven blanket on the top, we just remove the blanket, we scrap the solids. After that, we wash the blanket and put the blanket again in the top of the sand in the Biosand filter. If the Biosand filter do not have the no woven blanket, we need to stir the surface area of the filter with the fingers, wait the sand settle for 1 minute, discharge the supernatant water, and repeat the process until the water is clean. So the maintenance is very important, okay, and it's very easy to do. So the Biosand filters have been modified. Our partners here in Brazil, we work with a lot of modifications, either by the construction material, the depth of the sand bed, the sand grain size. So here we work with PVC pipes instead of concrete. We work here with PVC pipes and fittings. So it's very easy to get these pipes and fittings in hardware stores, and it's cheaper. We have some studies in fluid dynamics. We have working also the research with plastic float valve to maintain the water flow through the filter, the flow rate. We have worked with different depth of sand bed. We work with no woven blanket. We have different diffuser plate. The Biosand filter has been part of research in intermittent and continuous flow, the source of the water. So some studies we have with river water, or some studies we have with groundwater. So the different kind of water, the filter has different kind of efficiencies. So that's very important on research too. But in the final, the filter works very well. Okay. One important thing about the Biosand filter is that it requires good quality of water. Okay. And in one of my studies, to improve the Biosand filter efficiency, we put a pre-treatment step. Okay. So is the last part I will talk about today is about the household multi-stage filtration. Okay. So what we got here? So here we have the household slow sand filtration or Biosand filter, and we got a pre-step with a dynamic gravel filter. Okay. This kind of technology works well, treating 25 to 100 liters per day. Okay. The dynamic filter got a very good turbidity removal, E. coli and protozoa removals, and for this type of filter. Okay. Here's it's just a picture of the dynamic gravel filter. It's very simple. So we have a PVC pipe with 3 layers of gravel, a fine gravel, a medium gravel, and a coarse gravel. In the top, we put a no woven blanket. So we got water inside. The water flows through these 3 layers of gravel and goes outside by the tap. Okay. Here in the top, in the bottom, we have a valve that is used to clean the filter media. So it's very simple also to clean this kind of filter. We just to close the tap, okay, fill the filter with water, and just open this valve. So you're going to clean all the filter media, okay? So this was the pre-treatment step, and after that we got the slow sand, the household slow sand filter, or called Biosand filter, okay? And we got here a fine sand. This is the most important thing. This characteristics of the fine sand, their size, its size, the uniformity coefficient. So these characteristics are very important. Okay, this filter had 25 centimeters of height. After that, we got a coarse sand, medium gravel, and a coarse gravel. This is these three layers here. They are support layer, just supporting the fine sand column here. Okay, so the waters enter and go inside the filter, pass through the sand, pass through the gravel, and goes outside. Okay. So the results that we got with the household multi-stage filtration, we got turbidity removal more than 60%. 1.5 log is like 99%, almost 99% of E. coli removal, and more than 99% of protozoa removal. We work here with Giardia and Cryptosporidium, okay, cysts. The operation time that is linked with filter ripening parameter. The operation time influenced the E. coli and protozoa oocyst removals. The no-woven blanket acted as a physical and a microbiological barrier, improving E. coli and oocyst retention and turbidity removal. So the no-woven blanket is very important to the filter. It helps a lot. And the household multi-stage filtration with no-woven blanket is an example of a multi-barrier concept. What is this concept? That more than one stage to improve water quality with gradual removal of particles and microorganisms. Well, I think is that here there are the references, okay. And the most important thing that I need to say is to improve water, to improve access of water, to improve quantity and quality of water, we need to work together. So I'm very glad again to be invited and talk about water. Okay, so if you have any questions, you can ask.
Thank you, Professor.
My email is in the bottom here. Okay.
Thank you, Professor. You have given quite a brief about this Biosand filter, and there are a lot of questions for you. Shall I list out?
Okay.
Whether the turbidity of the water is more, whether it can be treated in this method.
Yes. For example, in the multi-stage filtration, the turbidity was more or less 40 NTU of turbidity. 40.
Okay. What is the difference and what will be the efficiency between slow sand filter and a rapid sand filter?
You can imagine.
Efficiency between slow sand and rapid sand filter.
Oh, the difference is the flow rate. So the slow sand filter, they work with 1 to 6 cubic meter per square meter per day, and rapid filtration works with 100, 150, 200 cubic meter per square meter per day. So this is have an implication on the area of the filter. Okay.
How often we have to replace the biosand in the filter?
In the filter, well, the biosand filter is very. We almost do not need to replace the sand. Okay, we need just take it. We can scrap the top of the biological layer a little bit. Is like 1 or 2 centimeters. Is very, very, very thin, thin layer of biological layer. We can take that, wash it, and put the sand inside the filter again. Okay.
And one more question, doctor.
Okay.
Whether this method can be applicable or used in our households for a middle income people.
For what? I'm sorry.
Low income or middle income.
I did not hear.
Hello.
Hello, I hear you now.
Yes, sir, I can hear you.
Okay, I'm
whether
hearing
it
you.
can be, whether it can be used in individual households, the people who are earning very low income.
Yeah, it can use in the Indonesian households. Yes, we have some partners in Mexico and in Colombia that work that are working with the biosand filter, and in this kind of the biosand filter that was projected by Professor Mans in Canada. They have more than 500,000 of biosand filter spread all over the world. Okay, so it's a very important technology that has a very good results. Okay.
Whether sea water, ocean water can be treated in this method.
Well, is this? I think it can be treated, but I don't know if there's research on seawater yet. So it's a research that we need to do. Okay. But I think that because this biosand filter needs the biological layer. Okay, so we have microorganisms in the biological layer that works and that works with predation to the pathogens in the water. And the seawater with what I can say that, well, microorganisms can be everywhere. So I think the biological layer will be adapted to the seawater, and the filter will going to work well too. I think it's that, but but I don't know if I have a research on seawater. Okay.
Uh, what will be the biological oxygen demand and chemical oxygen demand in this water?
The chemical oxygen demand was, I think, was 30 to 40 of chemical oxygen demand.
I think the questions have come to the answer. Um,
Okay.
uh, I thank Dr. Rafil from Brazil who have given a beautiful session, a very informative session. This session under this lecture was about treating water for household purpose for individual human beings, the people who are living in middle and lower income. As we are in a developing country, we could not spare more money in treating a basic need like water. I think in India, we people are having a treatment processes by non-governmental organization, private companies, and individual peoples are buying water, that is by spending some amount of money. I think this particular technology, if it comes to our India, in the people who are living congested or who are living in water scarred area, I think they will be benefited. Because we didn't saw 16 centimeter diameter of a tank like this biofilter. We have seen a large size of treatment processes and units which will be controlled by government as well as the private sectors. This particular model or this particular method can be made by particular method should be used by all the people, all the households, so that they will be benefited. I think I want to thank Professor Rafael on behalf of our EASWARI Engineering College, Department of Civil Engineering, and I want to thank our management who have given immense support to have this international webinar. They have given lot of supports and lot of things for conducting this webinar. And I want to thank our HOD madam and Professor Jyoti Lakshmi madam who have gave this opportunity to present a session for 160 participants all over India. Here professors are there, students are there, even few industrial peoples are available in this session. So this session will be an eye opener to every participants, and these participants can disseminate this idea to the other peoples so that they can adopt it, or otherwise even though a small community or a small group of people can able to use this technique and they can able to save their money as well as save their health. I want to thank once again, I want to thank Professor Rafil, who have given a very nice and a very good speech, because we are very much doubt in how we can able to understand the English, because Brazil, India, I think the language is quite easy for us to understand. I thank you very much, sir.
Okay, I thank you a lot too. I thank you again for the invitation. And I'm very, very happy to talk about the Biosand filter. That is a technology that I work, and I really love it to work with this technology. That I know that we have a lot of research and we know that this technology really works. Okay, so like you said, Professor, that a lot of people seeing this session, this webinar, I'm really happy with that, because I think that dissemination of this technology can really help people to have access to a good water quality, a good water with to access a water with a good quality. So I'm really glad again and the invitation. So I thank you a lot. Okay.
Thank you, Doctor. Thank you.
And just telling the last thing, if anyone wants to know more about this technology or has interest with this technology, you have my email. So if you want to send me an email, you can do it. Okay, and I'm very glad. Okay, thank you a lot. Bye to everybody.
Bye. Thank you.
Sir, attendance code.
Participants, the link and the attendance code is available for the feedback form. I think all of you have got a good knowledge, good knowledge sharing in this session. I think you people will disseminate this idea to your hometown or village, or some of the people who are struggling to get good quality water. This is what we want to share it, the knowledge sharing, the technical ideology sharing. I think this session would be a very useful session. Tomorrow also we are having a webinar session at 5 o'clock.
Sir, there is
PM.
a problem in link.
If you have a problem in link, please retry it, or otherwise please wait here. I will once again check the link.
Sir, what is the attendance code? Hello.
Attendance code is 001.
Okay, thank you, sir.
So
Sir,
can
it
you
is mentioned about how was the session, but that seems so blank.
Sir, in the feedback form, how was the session not to be edited, sir?
Fine, ma'am, no problem. I think the session was good. Wait a minute. Yeah, there
No,
is
sir,
an
there was an
option.
option like that.
Yeah, 1, 2, 3, 4, 5. Yeah.
No,
But it's
there was
not.
a radio.
Yeah,
Active
how was
select
the
an
session?
option, but there is no option at all in that.
It is available. Maybe you please re-enter the link.
Refresh, okay. I'll just try it.
Yeah, because there is a drop down 1, 2, 3, 4, 5 marks.
No, sir, nothing, sir.
Daya sir, if possible, please send the PPT, sir.
Yeah, we will share it to the mail, sir. We will share the
Yeah,
PPT.
okay. Very good, informative session, sir. They're very useful for the students. So only please I'm asking this PPT.
Yes, sir. This
Thank you,
is
sir.
actually this is the purpose of this webinar. So the students and professors and we people can able to disseminate this simple technology to all the Indians,
Yeah,
so that
yeah.
everyone can able to drink a pure water without spending money.
Yeah, yes, sir. Nowadays, it's very difficult to treat the water in poor people and the medium income people.
Yes, of course, of course. As we
The
people are in
technology
a
is very
middle class, we can able to afford 15 to 20,000 rupees per year for water.
yes, sir.
Others cannot able to afford it. Yeah.
Okay, sir. Send PPT, sir, please.
Yes, sir. Yes, sir. In a
Okay.
mail we will attach it, sir.
Okay, sir.
Maybe it takes some time. Okay.
Okay. No, don't worry. Okay, sir. Thank you, sir. Thank you.
Thank you. Thank you. I want to thank all of our participants, and the people can able to use this link and attendance code for the feedback. And tomorrow also we have the session, and we will give the reminder through the mail for tomorrow's session. Thank you
Sir,
for your participation.
sir,
Sir,
feedback
hello.
to be taken, sir.
Hello.
Madam? Yes,
Sir.
yes.
Hello.
Yes, sir. Yes.
Sir, actually, how was the session? So their link is not working, sir. There, no option is there.
Actually, there is a drop down, sir. 1, 2, 3, 4, 5.
No, not working, sir. Drop down not working.
Yes, sir.
Okay.
Sir, not
Okay. Okay.
Sir, drop down is working. Please wait a few minutes.
Yes,
Take
sir.
a few seconds. The how of the session is working. Just a few seconds
Yeah,
wait.
the browser
Until
could
it's
not
open.
able to adopt that drop down.
Okay,
session.
switch the
So
browser
you
to
have,
website mode.
yes. Yes. If you have problem in the feedback link, just close the browser and reopen it and refresh it.
Okay.
Good evening, sir. You can use desktop option. So it is more compatible for all devices. So I think all may use desktop option. So by using that, we may get the drop down option.
Actually, this Google form will be working in updated browsers. Many of you won't have the updated browsers, maybe that problem. If you're having a Chrome or a Mozilla Firefox, you can shift to that one so that this problem will be rectified.
Sir, no, sir. It's not working, sir.
Daya sir. Daya sir.
Madam, good evening, madam.
Good evening. Adi evalu try pantalu varla sir.
Use in your mobile phone, madam. Can you use in your mobile phone?
Yeah.
Because just now I checked it, it is working. Maybe it may have some problem in your browsers, so that you can use in your mobile phones.
Mobile only I am using.
No problem. You give that numbering number was 1 to 5 number is there, no ma'am? You can give that number and you can select that number. Okay, just now I tried it. It is working. Better you can try it out, ma'am. Once again.